Hey, Brent Ritchie here again. Today I'm going to use the normal distribution to calculate some probabilities. And there's three scenarios we have here. And if you happen to be in my class, these questions are on a review. And this first one would be number 11. But it reads, assume that the random variable x is normally distributed with a mean of 50 and a standard deviation of 12. Compute the probability that x is less than 65. So the notation we use looks like this. Probability that x is less than 65. Just sketching our curve here. We have a mean of 50. 65 would be over here somewhere. And less than implies this area here. We like these that use the area to the left because that's the area our chart gives us when we look it up. So that's the easiest ones to do. So all we really need to do is find the z for this, and we'll look it up. And remember, z is your value x minus the mean divided by the standard deviation, which tells us how many standard deviations we are away from the mean. 65 is the value we're interested in, minus the mean of 50. And that's all divided by 12. So I get 15 over 12, 1.25. I'm looking that up on the positive side of my chart here. Remember, you go down the z column till you find 1.2, and then you come over to the 0.05 column, find the intersection of those two. I get 0.8944. So the probability that x is less than 65 is 0.8944. And we don't have to do anything additional to this because that is the area that we're looking for. And that is the area that the chart gives us, the area to the left. Let's try a similar yet different problem. And if you're looking on a review, this is number 12. Assume the random variable x is normally distributed with a mean of 100 this time and a standard deviation of 10. Compute the probability that x is greater than 108. Probability x greater than 108. What would that look like? Something like this. Here's 100 in the middle. That's our mean. Here's 108 over here somewhere. Greater than, that's the area to the right. We need to calculate our z-score. Our x value is the 108 minus the mean, which is 100, divided by the standard deviation, which is 10. I get 8 over 10, 0.80. In my chart, I come down to the 0.8 row and look for the 0.00 column. And that is the value I'm looking for. Let me check my chart out here. 0.80, I get 7881. I get 0.07881. Now keep in mind, that is this side of the curve. The chart that we're using always gives us the area to the left of the value. We want the area to the right of the value. Since the area under the whole curve is 1, finding the area under the right is as simple as subtracting this from 1. And we get 0.2119. So the probability that x is greater than 108 is 0.2119. That's that area right there. One more. This would be number 13. if you're looking on the review. Assume that the random variable x is normally distributed with a mean of 70 and a standard deviation of 12. See, this is a good example of why we use standard scores. Every set of data has a different mean and a different standard deviation. So by standardizing it with z-scores, we get to use one chart for all our problems. Makes life a lot easier than having different charts for every standard deviation and every mean. All right, what's the probability that x is between 37 and 85? And the notation looks like this. X is greater than 37 and less than 85. So x is between two values. Here is 70, and these sketches are really not necessary, but I think they help understand what we're looking for. 37 would be over here somewhere, 85 over here somewhere. Between means this. And we know from the previous lesson that if we need to find the area between two values, we look up the z value for each value. Well, first we calculate them, then we look them up, then we subtract the smaller from the larger, and that gives us the area between. So let's find, first of all, the z value for 37 here. 37 minus 70 divided by 12. Let me get my little calculator out here. 37 minus 70 divided by 12. Negative 2.75. So this one is 2.75 standard deviations below the mean. Now let's find the z for 85. 85 minus 70 over 12. 15 over 12, 1.25. Now I need to look up the area in my table for each one of these. Negative 2.75. I go down to negative 2.7 and over to 0.5, and I get 0.0030. So that is the area to the left of negative 2.75, which is actually this area over here. And 1.25, looking that one up, 1.2, 5.8944. That is the area to the left of 85. So that is this entire area here, including this red part. So to find that black area, we take this green area and we subtract this red area, and that leaves us with the between. So 0.8944 minus 0.0030, we get 0.8914. So the probability that x falls between 37 and 85 is 0.8914.